Welcome back, everyone. This video is going to be slightly different from my usual ones. These questions are taken from a specific source. These are coming from a sample one from the final that's been posted in the department page. So I'll leave the link below so you can check it out. So I'll work these questions out. Hopefully they'll make sense. So let's go ahead and dive into them. For the first one, we're going to be integrating from 1 to e of the function ln of x over x dx. We're going to use the u substitution. So let u be equal to ln of x, then the derivative of u respect to x is 1 over x dx. And that's exactly what you have here. So that's why selection for u ln of x makes sense. Now, because we have limit of integration, and these belongs to x, I'm going to go ahead and switch them to u. So let's do that. You don't have to do it this way. I want to do it this way for this particular problem. So if u is equal to ln of x, that means if we change the limit of integration, we will have the new limit of integration. So when x is equal to 1, which is the lower limit for that, u is going to be ln of 1, that is 0. So that's our lower integration for the new integrals we're going to integrate. And when x is equal to e, u is going to be ln of e. And we know ln of e is 1. So our integral is going to become the integral of, so the lower limit is 0 and the upper limit is 1. And then we're letting u to be ln of x. So this is replaced with u. And du is going to be 1 over x dx. So this is just du. So that's what the integral becomes. And then when you integrate this using the power rule, you have u squared over 2. And now we can take it from 0 to 1. Since we already changed the limit of integration, you don't need to plug in what u is in terms of x. Now let's go ahead and plug in the upper limit of integration. We have 1 squared over 2 minus the lower limit, 0 squared over 2. And that would give you 1/2. So that is our answer to this integral. Okay, so now let's take a look at the second one. So this one, we will play around with a little bit and then use the u substitution. So I see that I have cosine here and cosine here of the same argument. So I can factor out one of the cosine 3x. So by rewriting the integral, we can write this as cosine of 3x times, so since I already pull out one factor of cosine 3x, you're left with cosine squared of 3x minus 1 dx. So just refactoring. Now here you want to use an identity. So let's recall an identity. So we know that sine square of x plus cosine square of x equals to 1. So if I want to somehow make this appear in the identity, it looks like I can subtract 1 from both sides. So, and then subtract sine square from both sides. So we can do cosine squared x minus 1 equals negative sine squared x. Now our argument is 3x, so I can simply rewrite the identity as cosine squared of 3x minus 1 equals negative sine squared of 3x. So that's the same identity. As long as you rewrite the argument, both sine and cosine has same argument. So that's where we're going to replace right up here. Cosine squared 3x minus 1 is negative sine squared 3x. So once we do that, our integral now becomes, we're integrating cosine of 3x times, now cosine squared 3x minus 1 is right here. That's negative sine squared of 3x dx. All right, so now that's easy to integrate. We can use u substitution. So I'm going to pull out the negative 1 and rewrite it. So we have negative cosine of 3x times sine squared of 3x dx. So just rewriting. Now we're ready to use u substitution. So let's go ahead and let u to represent sine of 3x. So the reason I'm choosing that, because this I can raise it to an exponent, rewrite as u squared, and the derivative is right here. That's why it's going to work. And then du would be 3 cosine of 3x dx. Now, since we don't have it 3 in the integral, you just need to divide that through. So this is 1/3 du is equal to cosine 3x dx. Now we're ready to rewrite the integral. So our integral becomes negative. So cosine 3x and dx is replaced with 1/3 du. And then sine 3x is replaced with u. So we have u squared times 1/3 du. And now we can use the power rule of integration to integrate this. We pull out the constant 1/3. We're integrating u squared du. And this is equal to 1/3 negative u to the third power over 3, of course, plus c because it's an indefinite integral. So we finish integrating. Now we can go ahead and plug in what u is. U is sine of 3x. I'm going to substitute that back in here. So this is negative 1 over 3 times 3, that's 9, sine cubed of 3x plus c. So that would be our answer to this integral. Now let's go ahead and try out our last problem right here. So for this one, we are going to be getting it from our memory. We're integrating 1 over the square root of 1 minus x squared. And this is just means, this means that x is between -1 and 1. And you'll see why. Now let's recall quickly. If you remember your inverse trigonometric functions, if you take the derivative of sine inverse or arc sine of x, you get 1 over square root of 1 minus x squared. Which means now if you integrate that, so you start to think backwards. If you integrate that, you should see that this will give you sine inverse of x. So therefore, based on that knowledge, we're going to claim the integral of 1 minus x squared dx is simply sine inverse of x plus c, of course. So that's how you would do this problem. Straight from the memory, there isn't much work to show. All right, so this is it. I hope these questions make sense.